Welcome everybody to Trig BootCamp Part 2. All right. In this video, we're going to be talking about radians, and then we're going to put together some stuff from Part 1, and we're going to solve some problems. So, let's start with a circle. I want you to pretend that the circle I'm going to draw is actually a perfect circle and not some crappy circle. There we go. Yeah, again, not the best circle in the world. Pretend it's a perfect circle. Okay, and so what we want to talk about is what a radian is. Okay, so here is a radius. We'll call it R. And let me do this. There's 90 degrees. There's roughly 60 degrees. We want to go just a little bit less than that. And oops, don't want to do that. Okay, and so here roughly, this is approximately 1 radian. Okay, so here's my angle. And now the arc length out here, the length along the circle, we call this S. Okay, and we have the following relationship between arc length and the radius, and that is S equals R times theta, where the angle has to be in radians here. Using this, we can solve for what 1 radian is. I can divide both sides by R, and I get that theta in radians is equal to the arc length divided by the radius. Now, if I set this equal to 1, what I wind up with is that the arc length equals the radius. So what this tells us is that 1 radian is exactly the angle. It's the angle made on any circle where the arc length is equal to the radius. Okay, so if the radius equals the arc length, that's 1 radian. Okay, and what we have actually, what's interesting about this is that it takes exactly pi radius units to make 180 degrees. Okay, so in other words, we have the following extremely important relation, and that is the following, that pi radians is exactly the same as 180 degrees. Okay, so pi radians equals 180 degrees. And we can use this to figure out how many degrees are in 1 radian. If we divide both sides by pi, we get that 1 radian is exactly pull my calculator up here. So if I take 180 and divide that by pi, then I get 57.29, yeah, I get this number here, 57.29 degrees or 57.3 degrees. Okay. This is approximately 57.3 degrees, okay? So what this tells us is that 1 radian is barely less than 60 degrees. So we can use this to understand how much 1 radian is, okay? So again, the concept, 1 radian is when the arc length is the same as the radius, and then the thing to understand is that there's exactly pi radians at 180 degrees, and therefore we can use that to conclude that 1 radian is 57.3 degrees. Okay, so let's use this information to solve a problem. And before we do the problem, we do need a little bit of background. Okay, let's look at 2 triangles. Okay, so there's 2 special right triangles. there are two special right triangles. Okay. Let's start with an equilateral where all sides are exactly the same. If all sides are the same, then all angles are going to be the same as well. And each angle will therefore be 60 degrees. So every angle is 60 degrees. And now what we're going to do is we are going to cut this thing in half. Okay. We're going to cut it in half, and we're going to let one of the sides here be 2. Okay, if this side is 2, then that means this side is 2, and that means that this side has to be 2, because all the sides and angles are the same. Okay, now what we can do is we can zoom in on 1/2 of this thing. And what we wind up with is not a 30, 60, 90, but a different triangle. I'm sorry. What I meant to say was we don't wind up with an equilateral triangle. We end up with something different, and that something different is a 30, 60, 90. Oops. Okay. So anyway, here's the point. I cut this angle in half, and that angle's right here. So I took a 60-degree angle and cut it in half. So that means this angle has to be 30 degrees. Okay. This is 90 degrees because this line is coming straight down. And lastly, this angle, as we can see, this angle is actually untouched from the original triangle. So this one is 60 degrees. Okay. And again, for simplicity's sake, we're assuming that this side was 2. So this side is also going to be 2 because it hasn't been touched. This side down here was cut in half. If I take 2 and cut it in half, I get 1. And if I use the Pythagorean Theorem, to find this side over here, because I have a right triangle, then what I'm going to wind up with is, 2 squared. 2 squared minus 1 squared equals the unknown squared. 2 squared is 4, 4 minus 1 is 3, so I get y squared equals 3. Therefore, y has to be the square root of 3. If I take the square root of both sides there, y equals square root of 3. Okay, so here are the numbers for the 30, 60, 90 right triangle. The other special right triangle that we have to know about is the 45, 45, 90. So again, here's 30, 60, 90. And then 45, 45, 90, in my opinion, is even simpler. Oops. So for the 45, 45, 90, what we're going to do is we're going to make both sides the same length, and then we're going to connect them. Okay. So here's my 90-degree angle. We're going to assume that one side is 1 here, and these sides are identical. So that means 1 has to be over here. And then, once again, we have a right triangle, so we can use the Pythagorean Theorem to find this side here. And so we're going to use Pythagorean Theorem once again. 1 squared plus 1 squared equals r squared. 1 plus 1 is 2. R squared equals 2, therefore r equals the square root of 2. Okay? All right. So there we go. 45, 45, 90, 30, 60, 90. Here's 45 degrees. So that same angle is going to be over here as well. We got two 45-degree angles and 90 degrees. And we have these numbers here. 1 square root of 2. All right. So there we go. We got our right triangles. We know what radians are. And so now we are able to tackle a problem like this. All right, so here we go. Okay, so first, 3 pi over 4. Well, pi is 180 degrees, so we get 3 times 180 over 4. 180 over 4 is 45. 45 times 3 is going to be 135 degrees. Okay. And so 135 degrees, let's think about what quadrant that's in. That's bigger than 90, less than 180. So that's actually going to be a quadrant 2 angle. And in quadrant 2, x is negative, y is positive, and let's remember that r is always positive no matter what. Okay? And so we wind up with the following. Okay, so 45 past 90, or 45 before 180. Okay, so we draw the angle as such, something pointing that way. And then we always sort of, drop this down to the nearest x-axis. Okay, drop it down to the nearest x-axis. Students mess that up all the time. Okay, so here's the point. This is 135 degrees. All right, so then this angle, this is called the reference angle. Okay, so let me just write that down here. This is the reference angle. And we can find that quite easily because we should know that 180 degrees is the negative x-axis. So the reference angle is going to be 180 minus 135. And that is just going to give us 45 degrees. And that tells us that we're going to use the 45, 45, 90 to solve this problem. Okay, so this is a 45, 45, 90. I can put my numbers here. 1, 1, square root of 2. All right, and x is negative, y is positive, and r is always positive. Okay, all right, now which one's x, which one's y, which one's r? Cosine is x over r. So here's x, and here's r. Okay, so what this means is that the cosine of 3 pi over 4 is 1 over square root of 2. Okay. I got a lot of the same color up here. Let me come down and let me change my color for this result. So we say, so cosine of 3 pi over 4. X over r. So it's going to be negative 1 over square root of 2. Okay, so there's that. All right, let's move on before we put it all together. Sine of 11 pi over 6. Okay, well, first, well, let me do that. Let me do this. Let me box this off. All this goes for the first term. Okay. So now, 11 pi over 6. Well, that's 11 times 180 over 6. And do this easy. Make this easy for yourself. 180 divided by 6. Well, that's 30. So we get 11 times 30. 30 times 10 is 300. Add 30 more, we get 330 degrees. Okay? Let's think about what quadrant that's in. Okay? 330 is bigger than 270, less than 360. So this is going to be a quadrant 4 angle. In quadrant 4, x is positive, y is negative, and of course r is always positive no matter what. Okay? So now we can sketch our angle. Okay, so here we are. Something like this. It's 30 degrees before 360, okay? So again, this is 330. And if I go all the way around from 0 and I go a full revolution, that's 360. So the reference angle, here's my reference angle. My reference angle is going to be 360 minus 330, okay? Or 30 degrees. So this guy is 30 degrees, or pi over 6, okay? And this is going to be the 30, 60, 90 right triangle, okay? And so what we have to understand is that 1's across from the 30, square root of 3 is across from the 60, 2's across from the 90, x is positive, y is negative, so we got a negative 1 there, and r is always positive, okay? Now, here's the x component, here's the y component, here's the r component, okay? So sine is y over r. So the sine of this thing, so the sine of 11 pi over 6, the sine of 11 pi over 6 is y over r. And y over r is going to be negative 1 over 2, negative 1/2. Okay, so there's that one. All right, now let's see, tangent of 4 pi over 3. Okay. Tangent of 4 pi over 3. Okay, so that all goes to term 2. Let me change my color. All right, so 4 pi over 3. Well, that is 4 times 180 over 3. 180 over 3, that's going to be 60. 60 times 4, 240. Okay, so that makes this a quadrant 3 angle. Because we're bigger than 180, less than 270, okay? In quadrant 3, x is negative, y is negative, and r is positive. R is always positive, everybody. All right, now let's sketch our angle. 240 degrees. Okay, here's 180. 240 is going to be just 30 away from 270. Okay, so there we go. There's our 240 degree angle. And now if I, draw my little side perpendicular to the x-axis there. Here's x, here's y. And now here's the thing, right? Here's 240, and then 180 is over here, okay? When I draw that down, I want to think about what angle that is. So I can get my reference angle. Okay, here's my reference angle. My reference angle is going to be 240 minus 180. Okay, and that's going to give me 60 degrees. So this angle here is 60 degrees. Therefore, I'm going to be using the 30, 60, 90 right triangle. 30 is going to be down here. Okay, so I'm going to have 1 here. I'm going to have square root of 3 here. And I'm going to have a 2 here. And let's remember x and y are both negative. So negative, negative, positive. So there we go. Okay. Now the tangent is the y component over the x component. And the y component is negative square root of 3. The x component, negative 1. Which gives me just regular positive square root of 3. Okay? So there we are. There's each piece. There we go. All right. So now let's put all this together. Okay. So we have we have 10 cosine 3 pi over 4. Okay. So this is 10 cosine 3 pi over 4. Well, that's just going to be 10 times negative 1 over square root 2, okay? Which you can write as negative 10 over square root of 2. But you can also write it this way, negative 10 over square root 2, and then we can rationalize the denominator by multiplying top and bottom by square root of 2 over square root of 2. And then that'll give me negative 10 square root of 2 on top over square root of 2 times square root of 2, that's square root of 4. Square root of 4 is regular 2. Negative 10 over 2 is negative 5. So I get negative 5 square root 2. So either one of these are perfectly fine. 10 over square root of 2 or negative 5 over, or negative 5 square root of 2. These are both the same. Okay, now for the sine of 11 pi over 6, we get negative 1/2. So we have negative 8 times negative 1/2, okay? So for the second bit, negative 8 times negative 1/2, well, negative 8 times negative 1 is positive 8 over regular 2 is just regular 4, okay? So the sine bit here in blue will just turn into a 4. And then the tangent part is literally just square root of 3. So we get 4 square root of 3 for this one. 4 square root of 3. Okay. So now let's finally put this all together. All right. We're going to have 10 cosine 3 pi over 4, which we found was negative 5 square root 2. and then plus 4, and then plus 4 square root 3. Okay, so we get that number there, and that's it. Okay, that's exactly what this problem is. Problem finished. All right. So there we go. Radians to degrees, degrees to radians, 30, 60, 90, 45, 45, 90, and a full example involving all of it. So there we go, everybody. Okay.